So, good morning, children. So, in the previous session, we were discussing about the law of triads, okay, for classification of the elements. And what Dobereiner did, he arranged the elements into sets of three, where the average of the first and the third element was equal to the atomic mass of the middle element, okay, and they were similar in properties. But there were some drawbacks of the Dobereiner. I hope you must have read it. So what was the first drawback of Dobereiner's triad? That he could identify only three triads which were satisfying his principle and as well as the properties. Then another drawback was he could not arrange all the similar elements into set of triads, and some of the triads which he designed were not similar in their properties. So these were the major drawbacks of Dobereiner. But then there was one major lesson to be learned from the Dobereiner's classification. What was that? What he started doing is he grouped the elements. So the other scientists came to a conclusion that yes, elements could be grouped, and grouped on what criteria? Maybe some of the properties, chemical properties, and as well as their atomic mass, which is one of the physical properties. So though Dobereiner's classification was a failed attempt, he was able to give a clue to the other scientists to carry on the work. And what was that? Grouping and taking the properties as the criteria for classification. So continuing with this effort, another scientist by name Newland proposed his own law. Okay, so today we will be discussing about this law, which was called as what? Newland's law of octaves. Okay, now Dobereiner said law of triad. Now Newland says law of octaves. Octa means 8. So that means he arranged the elements in set of 8. Okay, in set of what? 8. And in what order? In the increasing order of the atomic masses. Now, why he used this word octave and why he arranged them in the set of 8? Now, what Newland observed is that when he kept on arranging the elements in the increasing order of the atomic masses, he found that like the 8th element, the 8th note of a music, in the music, which will be the repetitive of the first, the 8th element was also the repetitive of the first element with respect to their properties. Okay, so what he did, like how the musical notes, in the musical notes, the 8th note will be the repetition of the first note. In the same manner, when elements were arranged in increasing order of their atomic masses, the 8th element had properties similar to that of the first element. Okay, so now let us see. So if you see, this was the arrangement done by Newland. Okay, now these are the musical notes, the Indian musical notes and the Western musical notes. Of course, you must all be familiar with the Indian musical notes. Starts with sa, re, ga, ma, pa, dha, ni. Again, the 8th note will be sa, isn't it? So similarly, here also, he started arranging from hydrogen, then followed by lithium, beryllium, boron, carbon, nitrogen and oxygen. And the 8th, fluorine, was similar to hydrogen with respect to the properties. Okay. Can we say he was right? Yes, because if you know, both are non-metals and both are gaseous. Okay, and they are going to form the covalent bonds. Okay, then now let us come and form acidic oxides. So now let us come to the next one. This one, if you see, lithium, then sodium. So lithium was if lithium was the first element, its 8th element was sodium. So sodium had similar properties to that of lithium. Both were metals, both were electropositive, okay, and both existed in solids. So similarly, even potassium. So now if you identify this is another set, children. Yes, the triad, Dobereiner's triad. Okay, so Newland's periodic table was successful in accommodating the Dobereiner's triads as well. Okay, so he could see that there were repetitions of the properties by the 8th element. So if we put the law, it says Elements are arranged in the order of increasing atomic masses. The properties of the eighth element, starting from any given element, are a repetition of the properties of the first element. Okay, so now this was the periodic table which was proposed by Newland. So if you see how many columns he designed 7 columns. Okay, so 7, and the next element was considered as the 8th. Okay, so like this he could arrange all the elements at that time known up till thorium. 56 elements he arranged in a periodic table. So this was Newland's periodic table. Keep in mind, children. Okay, so clear with this? So what was his achievement? We can say he was able to group the elements into columns and rows. Okay, that was his first element. And one more major achievement of Newland was he said that there is some periodicity. Now what do you mean by word periodicity? Periodicity word means the recurrence of certain characteristic. Okay, so was there a recurrence of certain characteristics? Yes. So if I take up lithium, the properties of lithium were repeated by sodium. Similarly, if I take up hydrogen, the properties were repeated by fluorine, and fluorines were repeated by chlorine. So, two major achievements of Newland's law of octaves were: 1, grouping of elements into rows and periods; 2nd, the repetition of the properties. Now, what are rows? These horizontal arrangement is called as rows, and the vertical arrangement is called as columns. Okay, so now there were repetition of the properties. Am I clear? But then there were also some drawbacks. So let us observe what are the drawbacks. Okay, now observe this table, children. Do you see any gaps being left over here? No gaps, isn't it? The first major drawback of Newland's was he thought that there were only 56 elements in nature, that is up till thorium. So keeping his thought that only 56 elements existed in nature, he did not leave any gaps in his periodic table. That was the first major drawback. Why? As of now, we know that there are now close to 118 elements and more to be discovered in the future, isn't it? So that was the first drawback. Did not leave any gaps, and presumed that only 56 elements existed in nature, with thorium being the last element. Okay, coming on to the second drawback. Now, his law of octave was only applicable up till calcium, that is the lighter elements. But beyond this, their properties were not getting repeated. Okay, they were not getting repeated. Let me take an example here. If you see chlorine is a non-metal, gaseous, electronegative. Come below it. Okay, below it, who is lying? Cobalt and nickel. Now what are cobalt and nickel? You all know they are metals, electropositive, solid in nature. So is the property of the chlorine repeated by cobalt and nickel? No. Then again come to next, cobalt and nickel. The eighth element for cobalt and nickel is bromine. Bromine is similar to chlorine but not to cobalt and nickel. So the periodicity was not continued after calcium. The properties were not repeated regularly. They were repeated but not regularly as he proposed as the eighth element. This was the second drawback. And the third drawback. Observe this, children. Now, as I told, cobalt and nickel are what? Metals. They are solids. They are electropositive. But come to chlorine, gaseous, electronegative, non-metal. So what he has done? He placed the unlike elements in the same column. Okay, unlike elements in the same column, whereas like elements were kept far apart. See over here, cobalt and nickel, and move to iron. So iron is similar to cobalt and nickel but placed away from cobalt and nickel. Okay, but iron is dissimilar to sulfur or oxygen, but it has been placed with them. So the third drawback was unlike elements were grouped together and like elements were kept apart. Then the fourth drawback, that is, in order to satisfy his law of octaves, he placed more than one element in the same slot. So if you see here, cobalt, nickel being kept together. Similarly, cesium and lanthanum are also kept together. Okay. Similarly, platinum and iridium. So these were his drawbacks. So let us this is what we have discussed just now, children. Achievements, and these were the drawbacks. I hope you are clear with this law. What was the law? Law of octaves. Hope you will be revising it for today. Thank you, children. Have a good day.